Good day, class. You are welcome to the Lagos State e-learning program. I am Afolabi Adimola Ladapo. I teach mathematics. The topic we want to treat today is gradient and intercept theory of a straight line. Lesson objectives. By the end of the lesson, students will be able to 1. Calculate the gradient of a straight line. 2. Sketch the graph of a straight line whose equation is y is equal to mx plus c, where m is the gradient and c is the y-intercept. 3. Determine the equation of a straight line from a given data. We can recall that a straight line is the shortest distance between 2 points. Given 2 points A, coordinates x1, y1, and B, coordinates s2, y2, to form a line AB, we can define the gradient or slope of the line AB as follows. Gradient AB is equal to increase in y all over increase in x in moving from A to B along the line AB. That is the ratio y2 minus y1 all over s2 minus s1, or y1 minus y2 all over s1 minus x2. On the Cartesian plane, this is described as follows. The gradient or slope of a given straight line is generally described by the change in the value of the vertical y divided by the change in the horizontal x. By trigonometrical ratio, we have y2 minus y1 all over s2 minus s1, which is equal to tan theta, where theta is an acute angle. Also, let us consider a situation where we have a negative gradient, as we have in the following diagram. Cn, that is, the modulus Cn is equal to increase in x, and modulus Nd is equal to decrease in y, or a negative increase in y, and beta is an obtuse angle with the x-axis. Since the straight line with points C and D run down to the right, the angle beta is therefore negative. At a glance, the following suggests the result of the slope of a given line. In the diagram above, the Roman figure 1 has the straight line runs down to the left, hence the positive gradient. Roman figure 2 has the straight line runs down to the right, hence the negative gradient. Similarly, the Roman figure 3 has a line runs parallel to the x-axis, hence the zero gradient. Meet you after the timeout. Welcome back, class. Let's look at some examples on gradient of a straight line. Find the gradient of the line joining each of the following pairs of points. Roman figure 1, P with coordinates 3, 2, and Q, coordinates 5, 6. Roman figure 2, X, coordinate 3, 0, and Y, coordinate -2, 2. Roman figure 3, R, coordinate 1, 3, and S, coordinate 5, 3. Now the solution. We shall recall that gradient is given by change in Y all over change in X. Roman figure 1. Gradient of PQ, coordinate x1, y1 is equal to coordinate 3, 2. Coordinate x2, y2 is equal to coordinate 5, 6 correspondingly. Therefore, gradient of PQ is equal to y2 minus y1 all over x2 minus x1, which is equal to 6 minus 2 all over 5 minus 3, which is equal to 2, a positive gradient. Roman figure 2, gradient of xy is 2 minus 0 all over minus 2 minus 3, which is equal to 2 over minus 5, which gives us minus 0.4, a negative gradient. Roman figure 3, gradient of RS is 3 minus 3 all over 5 minus 1, which is equal to 0 all over 4, which gives us 0, a 0 gradient. Note, no matter any point we pick on a straight line, the gradient remains the same. For example, in the diagram, here we have point B, C, D on it. Gradient BC is 4 minus 3 all over 5 minus 3, which is equal to half. Gradient of CD is 5 minus 4 all over 7 minus 5, which is equal to half. Gradient of BD is equal to 5 minus 3 all over 7 minus 3, which is equal to half. Now let's look at the following y-path question. The vertices of a parallelogram PQRS are P with coordinates A, 7, Q with coordinates 7, 5, R with coordinates 0, 4, and S with coordinates 6, 2. Calculate the Roman figure 1, gradient of PQ. Roman figure 2, gradient of SR. Roman figure 3, value of A. Solution. Since the vertices of a parallelogram take after the order of the points given, hence the diagram as follows. Solution. Gradient of PQ will be 5 minus 7 all over 7 minus A, which is equal to minus 2 all over 7 minus A. Gradient of SR, 4 minus 2 all over 0 minus 6, which is equal to minus 1 over 3. Since PQ, the line PQ is equal to SR, and the line PQ is parallel to SR, that is, opposite sides of a parallelogram. Therefore, minus 2 all over 7 minus A is equal to minus 1 all over 3. Multiply both sides by the LCM. 3 into brackets 7 minus a, bracket closed. We have a minus 7 is equal to 3 into minus 2. A minus 7 is equal to minus 6. Therefore, a is equal to 7 minus 6, which is equal to 1. Since a is equal to 1, then gradient of PQ is now equal to minus 2 all over 7 minus a, which is equal to minus 2 all over 7 minus 1, which is equal to minus 2 over 6, which gives us minus 1 over 3. Meet you at the next segment. Welcome back, class. Now we look at equation of a straight line using gradient intercept form. Equation of a straight line using gradient intercept form. The linear equation of a straight line can be obtained if the gradient m of the line is given and the y-intercept also given. This can be obtained graphically as follows. If the gradient of AB is m and the y-intercept is c, then from the graph we have y minus c all over x is equal to m, which is equal to tan theta. Therefore, y minus c is equal to mx. Making y the subject of the formula, we have y is equal to mx plus c. Y is equal to mx plus c. This is called gradient intercept form of the equation of a straight line. Let's look at some examples. Number 1. Determine the equation of the straight line with gradient m is equal to half and y-intercept c equals to 6. Solution: m is equal to half, c is equal to 6. Since y is equal to mx plus 6, therefore y is equal to half x plus 6. Multiply through by 2. Then we have 2y is equal to x plus 12. Number 2. Excuse me. Find the coordinates of the points where the line represented by the following equation cross x axis. Hence, sketch the graph. Y is equal to 2x minus 4. Now, solution: x-intercept. That is when y is equal to 0. That is 0 is equal to 2x minus 4. Therefore, x is equal to 2. By definition, y-intercept is minus 4. And the line crosses x-axis at x is equal to 2 as shown in the diagram below. Therefore, the line crosses x-axis at the coordinate 2, 0. So, thank you. Let's look at the following practice exercise. 1. Waec 2010 objective test numbers 39 and 40. Number 2. Waec 2014, objective test number 17. Number 3, Waec 2017, objective test number 21 and number 22. Thank you. Meet you later.